The second video of 2.3 is dealing with the different properties of the dot plot. The big three, commutative, distributive, and associative, all work as you would expect. I'm going to illustrate at least the first one. You have other ones in your book, other proofs in your book, or showing you exactly how these properties work. Let's talk about the commutative. So u dot v, recall it looks like u1 v1 plus u2 v2 plus all the way to, we say, un vn, whereas v dot u is the same thing, only these are in reverse order. So v1 u1 plus v2 u2 and so forth. So this should be a v and this is a u. But note, u I vi equals vi ui for all I. So we had the exact same thing. All right, so let's try to take care of this problem down here. We're looking to find a dot b and then multiply that by c. Now when we take a dot b, that's going to be a scalar. So this will look a little different, but let's see. These two should be different. Well, I guess they could be the same, but let's check them out. All right, so first of all, a dot b is going to equal 2 times -4 plus 0 times -7 plus -3 times 1. And this equals -8 plus 0 minus 3, which is -11. So if I then have -11 times c, that's -11 times the vector components of c, which are 1, 1, and -1. And this equals -11, -11, and +11. Let's take a look at a dot c, however. So a dot c and then multiplied by b. A dot c is going to be 2 times 1 plus 0 times 1 plus -3 times -1. Again, we're using, there's my 2, there's the 1. There's my 0, there's my other 1. And there's my -3, and there's my -1 for these different values. So there's my blue. Green and yellow for this. All right, well, at any rate, this equals 2 plus 0 plus 3, which equals 5. And then I need to multiply that by my b vector. So then we have 5 times b, which is 5 times -4, -7, and 1. Remember, we distribute that in, so that's just going to be -20, -35, and 5. So again, they're not the same. We can't just start moving those around willy-nilly, but they will follow the above properties.